Dear Mr. Adam, the equipment of your order is ready for packing. In this video, I'm going to show you how to assemble, how to install, and how to work with these three machines that is used for ISO and Charpy impact testing of plastic materials, from the raw material sample preparation here on desktop injection molding, manual injection molding with the temperature control panel. Here we have notch milling machine to prepare notches, and here we have the testing machine itself. It's ISO Charpy impact tester from AHP Plastic Machina. Step by step I will show you how to use the machine. First, I'm going to prepare samples from the raw materials. Machine is like this. It has turning head, a reservoir for sample, You can fill the hopper as much you need. It's enough. Yeah, for example, you have grip for the sample. For the mold, you have grip for the mold. If you turn the head to the left side, the hopper will be in front of the cylinder hole, and you can easily fill the cylinder with the material. You have grip for the mold. The mold is like this. I'm opening the mold to see what's inside. It's an aluminum mold. Yes, this is sample aluminum sample mold for the ISO Charpy. Just close the mold. When you receive the machine, you need to connect the cables. On the back side of the machine, you have cable connections. This is the main cable, including the power cable. The right one is power, and the left one is the sensor cable that measures the temperature of the cylinder. You have aluminum table. You can fit the table from the bottom side. I just used four screws from underside of the table to fix it on the table. You have grip. You can easily fix the grip in the position that is suitable for your specific mold. Just put the mold in the grip, and first of all you need to adjust the head height. The height of the head, you have two types of the nozzles, brass nozzles. This is the first one. The other one is the first one was the standard nozzle. The second one is automatic shut-off nozzle that is used for very high flow materials. When you push it, you see the valve will be open and the material will come up. It is very useful in making samples from the very high flow materials, and it's easy to use in such cases. First of all, you need to put the mold in the grip. You put the mold in the grip and adjust the height of the head assembly on the machine in such a way that you have a little distance between the nozzle, the end point of the nozzle, and the top surface of the mold. You can easily set this distance using this screw here. Here you have a screw. You can open it, loosen it, set the height of the head in such a way that you have very low distance between the end point of the brass nozzle and the top surface of the mold, and then you can tighten the screw. Now it's ready to work with it. As I said, you can easily fill the hopper, then turn the head to the left, bring the piston up, turn it to the left. In this way, the hopper will be in front of the cylinder and the material will flow into the cylinder, and then turn it to right, and it's ready to work. Yes. Cut the excess material that is out of the nozzle. When you fill the hopper and fill the cylinder with the material, you can set the temperature. The temperature is according to the material is going to be tested. Just click on the mode key and you can easily set the temperature with the up and down arrow key. After setting the desired temperature, then click on the mode key again, and that's all. After you fill the cylinder, you see the brass nozzle has not any heater on it, and the material that is inside the nozzle is with a temperature lower than the material temperature inside the cylinder. That's why before starting the test, just push the nozzle upward, bring some material out, that the material that is some colder than the material inside the cylinder, and now put the mold inside. That's all. Put the mold inside. Yes, then push and fill it. You see here the holes for the exhausting of the air that is tapped inside the mold, and then after the mold is filled, just keep the handle with less force in this way, so that when the material is cooling inside the mold, you don't have any bubble on it. And in this way, you will have samples without any bubble. Yeah, then release it. That's all. Wait for some minutes, 2 minutes, 1 minute, then open the mold. Yeah, you see it's just the mold is filled. You can cut the runner, the gate material. You can do the cutting. You can do the cutting before the material is completely cooled down. Yeah. Then the sample is ready. Just trim it. Now we have sample ready. These marks, these black marks are for the material that were inside the cylinder and just burned and so on. These black marks are because of this. You know that for each material there is oxidation induction time that you can keep any specific material in hot area, for example 230, 250 and 200 in maximum definite time, and more than that time of course the material will be oxidized and you will have burnt material. Then you need to do the process, the whole process in definite time to have the good standard samples in hand. As you see, it's very easy to work with the machine. Another point is this screw here. It should not be much tightened. It should be loose for a while, that you can easily turn the head. Yeah, you can easily turn the head to left, the middle and left position. Yes. Then after sample prepared, I'm going to make notches on the sample. Then I'm going to the second machine here, that is notch milling machine. It's easy to work with it. Just fix the sample. Just fix the sample in the grip. It should be in the middle. Yeah. Tighten the screw. Yeah, when the bolt is tightened. After you tighten the sample, just bring the sample back. Open the screw. The sample is coming back. Then run the machine. Yes. Then bring the sample forward, turning the screw to right. And take a look at here. When the sample touches the cutter, it is a 0 point. After the sample touches the cutter, you can easily zero the indicator. Now the sample touches the cutter, you can easily zero the display. Now it's 0. Then I'm going with the distance for the depth of the notch that is specified in the standard. Yeah, going forward with the definite value of the standard for the depth of notch, and it makes the notches on the sample. Yeah, like that. When the notches, when the travel done, the travel of the sample piece toward the cutter done according to the definite value of the standard, you can stop and bring the sample out. Now everything is ready for. Now we have two types of sample piece in hand: one notched, one unnotched, and one notched sample piece. As you know, you have two types of test sample: unnotched and notched. Now we have fixture of you see the fixture of Charpy, and this hammer is Charpy 5U, and this is the fixture for the Charpy test. You can easily set the height of the sample grip like this in the middle of striker. You see a marking here in the middle of striker, and you can easily adjust the height of the sample piece so that it should be in the middle of the striker, aligned with the line here, the marking line here. You can easily adjust the height of the base for sample using these two screws here and two in the back. You can adjust the height of the sample piece. Now it's ready for testing. Just turn it on, turn the machine on. Yes, you have here two position. The IZ 5 joule is 148 degrees here. This is the stopper for IZ. And the other one is Charpy 5 joule, 107.21 degrees. Yeah. You need to set those angles here. When you change the fixture and the hammer, you need to set the angle here. Now it's in the 0 point. Just click 0 and set the release angle. Now we have Charpy. The Charpy release angle is 107.21. And here you will set the angle here, 107.21. Yes. Now, when the sample, the hammer is in off position, you need to click on cal, meaning calibration. And also here you have three figures. The mounted weight is 5 joule. that is in the middle, you need to set that to 5 joule. Yes, the other will be calculated automatically. Now the other point is the measurement of the friction loss. I'm showing you how to measure the friction loss. Yeah, you are in friction loss measurement page. Now, without any sample on the grip, you have hammer for 5 joule, release the hammer. And here you will have the sample energy, you will save it as friction loss. Just click on FL and the machine will measure the friction loss of the hammer without any sample. Yes? Now we are ready for measurement. Just clear. First of all, just clear. You have 10 measurement points. Mount weight is 5 joule. You see on the top right corner the friction that the machine is measured. The machine measured the friction and the value is 0.33. Okay, now we are ready to measure Charpy. Okay, close the door. Release it. Yes. You have here the first sample energy. After measurement, you need to click on S1 for the sample 1 to be recorded here. Then go to the next measurement, up to 10 measurement you can do. You can do the measurement up to 10 sample piece. And every time you will click on S2, S3, S4 and that's all. And then you can save, you can print the results. You can save, set the sample parameters first. No, the sample parameters I'm showing you here. The test type is Charpy. Customer, operator, material, sample type was unnotched. The sample was unnotched. Yes. The width of the sample was 8, thickness was 4, and the length was 80 millimeter. Then now you can save. Now you can save it and print it. Anytime you save, the date, time, parameters, sample parameters, energy calculations, everything will be saved, and anytime you put a flash disk here, anytime you put flash disk there, you can easily save it to flash disk and transfer data to the PC. It's easy to work with it. The other hammer and the fixture type is for ISOT. This one is for ISOT and the hammer is for ISOT. You can easily change this fixture and hammer. Backside here, you have a knot. Just open the knot. Yes, release the hammer. Put the other hammer. Yes, just put the hammer in. tighten the knot. Just bring the hammer down, adjust the angle. Yes, adjust the angle, then tighten the knot over here. Done. Bring the hammer up. Yes, now you can change the fixture for the sample of ISOT. As you see, this hammer is ISOT 5 joule. You will open the 4 nuts here, 4 bolts here, and put the other type of the sample grip. Yeah, when you open those 4 bolts, then assemble the ISOT sample fixture. Bring the hammer down, and the zero angle of the hammer, the edge of the striker will touch the sample in 0 point. Just put a sample in the grip. Yeah, release the hammer. And in the 0 point, release the hammer. No, go forward. Yeah, release the hammer. And in the 0 point of the hammer, this is the 0 point of the hammer. Yeah. Yeah, move forward. The edge of the sample piece will touch the hammer, the striker edge. Yeah, here. Now you can tighten the bolts for the fixture. Before setting position for the gripper, you need to adjust the height of the sample gripper. There is a gauge here with definite thickness. The distance between the bottom edge of the striker to the top of the gripper will be as much this distance. Yes, this gauge is for setting the height of the sample, the height of the gripper. Yeah, now you see it's loose, and we want to bring the sample gripper upward for a while. Yes, for this purpose, just loosen these 2 screws. First of all, loosen these 2 screws, then loosen the knot here, and there are 2 edges. Yes, 2 wedges slide on each other and changes the distance of the top of the gripper. Yes, you easily set the height like this. Then after setting the height in such a way that this fixture touches the bottom edge of the striker, that is the right height for the sample gripper. Tighten that knot on the left side, and after the height is adjusted, tighten the Allen screws here. Now we're ready to set the 0 point of the striker. Just put the sample inside the gripper. That is the notched sample. Yeah, you will do like this. You see the notch of the sample. Yes. Yeah. Now the sample is in position. Then release it. Now we want to set the 0 point of the striker. Just bring the striker down. And in the 0 point of the hammer, move the gripper left and right so that the edge of the sample piece touches the edge of the striker. Yeah, this is the correct point for fixing the bolts here. Just tighten those 4 bolts. This is the 0 point of the hammer. And also we adjusted the height in such a way that the striker that just strikes the sample piece in definite height as defined in the standard.
0 point.
Now we will set the angle that is 148 degree for ISO. As you see, it's written here. Just calibrate it for ISO. Set the angle 148 degrees. Then click on cow and just set the 0 point. 0. And first of all, you also need to measure the friction loss as I demonstrated in the Charpy. Just go to the measurement now. Yeah, go to the measurement. Set the sample parameters to notch the ISO. Notch the ISO. Then customer sample parameters and go to the test page. Clear the data. Yes. Then start measurement. Yeah. Then save the measured energy value in the sample 1. Yes. Done. It's easy to work with it, and you have here ISO Charpy 5 joule. The other one is notch milling here. Fixture for the Charpy, control box for the manual injection molding machine, and everything is ready for packing. Thank you for your note.